I am setting up my equipment so that we can track time, pressure, and our combustion byproducts. A little bit. Foil tape. Okay. So the foil tape is so we can close the holes we make. A little bit is for making holes. So this allows me access, so I can put my pressure probe in here. And I just want to see how this thing is, what kind of pressure is being generated here. Is it a positive pressure where it's pushing, or is it a negative pressure because this guy is sucking the exhaust out? And I'm not imagining it's going to be a negative pressure because we don't have that vertical rise that we typically have with an atmospherically vented system. So my guess is that this guy is going to mostly be pushing the exhaust out. In which case we want to look for areas where it could be leaking out, leaking into the house. All right. So, turn this on. And we're going to go to 5-second averages for pressure. And what do we have so far? Nothing. So there's no pressure, there's no basically draw on this pipe at this point. It's effectively zero. Nothing's pushing or pulling. Hey Tim, you turn the water on at the slop sink over here? Yeah. Okay, for an on-demand water heater, it's not going to turn on until there's a demand. So there's no flip the switch on and have it fire. It's run some water, let the unit know that hot water is being demanded, and it'll turn on its own. So to fire it, you literally have to have, either scurry out and turn it on yourself or have somebody assist you in it. If you're going to turn the hot water on, make sure you're turning it on to a tub or a slop sink, some large vessel that can hold a significant amount of water without overflowing. Don't use a little lavatory sink. People wash their hair and the thing gets clogged and it might not back up right when you turn it on, but you're going to go back into where the water heater is. 2 minutes later, you don't realize that the sink is backed up and is now spilling all over somebody's floor. So generally you want to turn on a fixture that's nearby, or if it's not nearby, one that's large enough to hold a significant amount of water. Okay, so we've turned the water on at the utility sink in the laundry room, and when I hit the power, now it's seeing the demand for the hot water. It's starting its firing cycle, and we can see that we do have a positive pressure in that flue, so that fan is pushing the exhaust out. And as soon as this unit fires, we're going to start our timer, because ultimately we want to look at firing times. So now I'm looking for a safety switch because it doesn't seem to want to fire. I have the fan kicking on. That's the challenge with these, is you never quite know unless you're specifically familiar with a particular model from a manufacturer, what safeties there are. So you want to know generally how they work and what the firing sequence is. I don't see any safety switches on here. A lot of times when you remove a cover, it opens up a safety switch, but it doesn't appear to be the case. It's on. There we go. And fire. All right. How about some smoke, Tim? Thank you. Alright, so we can see that this fan is creating a positive pressure here because it's blowing. And here it's creating a negative pressure, so we can see it's sucking our smoke. And if necessary, do this. See a nice stream of smoke, and then here's where our dilution air is. And so we've got good airflow up through this unit. I would imagine that we wouldn't have much issue. I mean, we're creating 16 pascals of suction pressure with this fan. So I don't think we're going to have any issues with spillage. But we will go through and we will measure our readings at 1 minute intervals, starting for 5 minutes, starting at 1 minute. So at 1 minute, we have our CO air free got as high as about 63. Until we see 200s there, we're good to go. we have no exhaust spillage, and everything's being drawn out nicely. The other thing, like I said, I was going to look at, since I know this is being positively pressured, I want to look to see if there's any gaps in this line, because we can be blowing exhaust out those gaps. Now they did a fairly decent job with taping some of this, but where they didn't rub the tape down, gases have escaped and that's gotten dry. That's not going to stick once it dries out. So it really is important that the tape gets put down very well before we start pushing exhaust gases through, because it'll just dry out the tape. Alright, so we're at 2 minutes. Another reading. And we're fairly constant. It's CO air free dropped to 57, back to 61, so it's bouncing around 60, a little above, a little bit below. And again, still in a fine range. Something's loose. A little rattle when it runs. If you hear a weird vibration, just put a hand on it. Sometimes you can see it's just like a loose panel or something that's just rattling. So our DG700 manometer is basically just showing us that we've got a good positive pressure. This is pushing the exhaust out, and we've been anywhere from 14 to 19 pascals, which is fairly significant. You have to turn on a lot of exhaust fans to create a negative pressure that's going to be able to counteract that. So it has a good tolerance for opposing negative pressure. I think we missed our 3-minute mark, but we're going to look for 4 minutes. And at 5 minutes, the only other reading that we're going to take is the operating temperature. So we've been sitting around 260 degrees. And I pulled the probe away from the sidewall, and now it's looking at like about 330. So definitely the position of this probe can make a significant difference. And I just have it kind of in the center of the exhaust of our heat exchanger. There's really not any set spot to put it. If you wanted to, you can kind of move it around and do kind of an average of different areas. But I would imagine that the greatest heat would come right from the center, not so much at the edges. CO is coming down. Actually, I'm kind of curious. I'm going to put this probe back to the edge, give it about 20 seconds, and see if the CO is higher at the edge where I was originally taking it, as opposed to the middle where I moved it to. So it takes about 25 seconds for the air to come through this entire hose assembly and across our sensor. And now we're seeing it kind of tip up a little bit. So maybe the CO is a little bit higher around the outside edges, a little bit lower on the inside. And our CO is generally so low that it's higher, lower is still relative. We're in a low range, so 20 points one way or another is not making a difference here. And 5 minutes, we've got, again, our operating temperature, about 300. Let's see. You can shut that water off. And as soon as the water demand shuts off, the unit shuts off. Alright, and then we'll turn this off because we don't want to kick it on later in case somebody washes their hands. We're going to be running our blower door in a little bit, and so we can't have this guy turning on because of a demand. Not until we're done testing at the home. So for safety's sake, we're going to keep this guy shut off. And that's about it for this unit. Again, a little bit different. Typically single wall vent connectors are a negative pressure atmospherically vented system. In this case, it's a positive pressure. It's still really hot, so we do have to have a metal flue. We can't change this to PVC. But this is a positive pressure single wall venting system.